Hello, welcome back. This is Fredrik from Tech Nordic, and today I'm going to talk about how to generate a multi-channel and how to analyze it. I'm using an AWG70001 series from us, which has a maximum of 50 gigasample output. I will do all the RF, and this is the software control it, calling Source Express. There's a free download on our homepage where you can try. It has support for what we call a virtual generator, so you can just play around with it. So first I will start by doing this multi-channel, and we'll do it step by step, and it's going to be a quick introduction. So we're going to do two steps first. First of all, I'm going to just make something noise. So I do a DC level here and 0 volt, and I just press compile. That's it. And when I compiled it, I did it 2 times, compile it, it's there. Then I go into the RF generic signal generation tool. So the plugin starts, and here there's some things I want to do to make sure. I go to the settings here, and I want to have 50 gigasample manual. Okay. Next step is to add what we call multiple carriers. And we set the center frequency here. This is how I use it, 868. There's different ways of doing this, but 868 megahertz. And I set the bandwidth. The RSA507 have a 40 megahertz modulation bandwidth, so I will put this down to 35 megahertz. And I just say number of carriers. It could be, for example, 10. I think this is the QPSK. Symbol rate, yes, that's a good one. 1 megahertz is good away. And I will replace the carriers. When I've done this, I've done 10 of these signals, and you can see each one of these can be controlled. When I've done this first step, I can compile, and we just play it out. And then we will go back to this software, and I will add some other modulation schemes, etc. It's done, and I move it over here, channel on, and play. So now I'm playing. I have a small antenna here in my lab, and I go into this one. So we have 868 megahertz. I'm going to only use the DPX. It's kind of neat to look at. You know, I like it a little bit better, so we move this around. There's some few tweaks here. First, the amplitude. The 507, you have a controllable preamp, so I will just put it on, and then we go down to we have something. Yeah, we have a decent signal at least. And here you can actually see it's the same modulation. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of the signals. And if we move this one, you can see there's nothing over here and nothing over here. So this is our 10 signals. Next step would be for me to analyze one of these at a time, and this is how I do it. So first go to File, a View, and go for Navigator View. It's the 0 span, so you can put this up to maybe 500 microseconds or something, so you have some data. Second thing you need to set up here is under this analysis control, and this is the reason why it works is that unclock this lock center frequency of spectrum display to measurement frequency. And when I did this, you can see I have a little bit of a bar I can move around like this. This is actually telling me the tuning frequency where I'm looking. And the third and last one I will go in is the general purpose modulation for the constellation. So let's try to do some tests here. So we have this one. We need to set this up. We had a 1 megahertz. We'll put 1 megahertz. And we have QPSK. And we go for analysis time. We can go for 128 symbols or more. And we go for traces. And I want to see points. And this gives us an EVM. So here we are, and here you can see this kind of tab, and we can move along like this. So this tab and how it works in both the normal spectrum mode and is real time, but also if you go into the DPXogram like this, you can center it around this. Sometimes it's a little bit easier. I mean, it's really what you want to do. And it also works in the 3D, where you move this around. Just make sure that you put the point. And here you can see. It's not the best signal, it's not that strong, the signal, so the values are as expected. You probably can tweak this a little bit more, and the more we tweak, the better it will be, but it's not perfect. So I'm going to go back to the software controlling my RF generator or my arbitrary waveform generator, Source Express. I'm going to add something to this. So we have this number 1 here, the 850 megahertz. Let's make this QAM16. That's it. And let's make number 2 here. We add some impairments. And we can turn on IQ imbalance. Let's put it at 10%. I think that is about it. And then I just press compile. It will compile this, make a new file, and you can see the file size here is about 12 meg or something. It's I think up to 16 gig you can load this. So it's quite a lot of things. In this case it's 25.4, but 25 meg. And I'll take this one and drop it. And it will load it, and we can go back and see what's happening here. So after a while it will be loaded here again, and we can start analyzing. So what I did here is very simple, but you can see this one over here, and this is really good if you want to tune around or do things around, not the center frequency. So if you have a multi-carrier, you can do a lot of things. So we can move it. We play with number 1 and 2. So this is number 2. Here number 3 looks good. So number 2, here you can see that wobbling of the IQ imbalance back and forth. And this one over here, was that the 16 QAM? A bit tricky. I can see the 16 QAM, and you need to then to change this one to 16 QAM. Hopefully, and what was the center frequency? It was 850, 50 meg or something. Was it 851 or? Let me see if I can get this. QAM 16 is a little bit more of a. You need to know the frequency. If I look at this again, 850.5 is the one. So 850.5 megahertz is the actual channel, and here you go. You can see it. So if you know, now the antenna is a little bit moving around, but you can see it's not the best, but this is a antenna measurement. Okay, so this is a stable signal. Let's now go in and create a kind of a sequence of this. And I go up here in the home menu, there's a button called sequence. I take this track, which I did now, track 1, and I also did this DC. And we can, for example, add track number 2 and DC. And we repeat this 200, that's 200 microsecond, and we have a dead of 500 microsecond. I think this is it, and then we go back to first. So this is the loop now. We play the first original one with no problems, and we wait 200 microseconds. We play this one with a different modulation scheme, and we wait 500 microseconds, and we just repeat this one. I go to the sequence here, and I just load this. Oh, go home first, and I just load this track. That's it, and it's playing out already. So this is how that looks like. Of course, my antenna is not perfect, but you can see from time to time one of the issues you might come across. It's that the fact that it does demodulate the 0. This is where I'm using this one. So I put this to 500, or we can put it at 1 millisecond. No, that's to 2 milliseconds. And now here you can see that I have points in the middle here, and these points refers to nothing. So I need to make sure that the software knows where it's not working. So there's a find here, and here you can use burst detection. So if I put it on, it will only look at the burst and demodulate. So now I can move over here again. Of course there's a different modulation. That was QPSK, and this was the IQ imbalance from time to time. So let's see if we can capture one of those from time to time. Second thing, I'm just free running here. Second thing is you can move along this again. So, and lastly, I know this video is a bit fast, but lastly I will add the triggering, because the triggering gives us some features to look at. We know that every second burst has some problems. So if I go here for triggered, and I just move the trigger down to like 55 or something, I should have a more stable trigger, hopefully. Yeah. Not really. Okay, at least there's something. So you can see here, and I can move this around so I can look at different parts. And I can stop this now. We have several. We can stop this now, and I can look at only this burst over here, and I can replay. So if I go back to my the problematic one, I just replay. That's the 16 QAM, yeah. This is the one which is bad. Replay. Here it looks okay. Maybe it doesn't look okay over here, and I replay. Oh, so this is the problem, the burst that is bad. Yeah. I hope you enjoyed this short video. It was how to generate multi-carriers, different modulation forward, and how to use RSA and you know, particularly SignalVu-PC to try to look at how you can analyze it. And don't forget, you can always go to replay all. Thank you very much.
Find out more at Vicom's website.